Recall that expectation is the probability idea that corresponds to averages. In the case when we're looking at a discrete random variable, the formula for expectation or average of the variable is found by adding this weighted average. When you turn to continuous random variables, sums turn into integrals. So the expected value of a continuous random variable y will be found by integrating over the entire real numbers of y times the PDF. Just as in the discrete setting, you added over the entire real numbers of k times the PDF. Consider the following example. I will have PDF given by 2y between 0 and 1. Recall that this actually defines a PDF over all real numbers. Anything not in that interval has probability 0. The expected value will be integrating over the full sample space of y times that PDF. And to find that, you just break it up into pieces. We have some pieces where the probability was 0, and then we have the main piece where the PDF was 2y. Those 0 parts just integrate to 0, and the part that really mattered to us integrates as, well, let's see, we had y times 2y is 2y squared. That integrates to 2 times y cubed over 3. Plug in the limits, and you have 2/3. Now let's look at a different example that's a little harder. This time, the PDF has 2 parts. Again, the expected value is found by integrating y times the PDF. And again, you do this by adding up all the different pieces corresponding to this PDF. You have 0 in the regions that were not described, and then you have other values such as 1/2 between -2 and -1, which corresponds to the integral from -2 to -1 of y times that 1/2. Integrate each of these terms. The zeros integrate to 0. The blue parts, the interesting pieces, well, y over 2 integrates to y squared over 4. Y times y is y squared, which integrates to y cubed over 3. I've just shifted the formula up here to make some space for work. So plug in the limits on those terms, and then do some arithmetic. It simplifies to -5 over 12. Now, one habit that you've learned from probabilities is that if probability is not between 0 and 1, it's probably wrong. In fact, it's always wrong. However, this is not a probability statement. It's a statement about averages. Averages can be negative. Averages can be very large. So the -5 over 12, if you see an answer like that, you should ask yourself, does this make sense? Since we're looking at averages, it's okay. If we were looking at probabilities, it would mean an error had been made.